This one, we're going to be dealing with section 2.7. We're going to talk about combining functions. Now, part of this includes the good old polynomial you did where you add and subtract them. And part of what we're going to talk about, what we're going to do first, is adding, subtracting, multiplying, and dividing these functions. Okay, now the domain of the resultant function is the intersection, and we talked about this in set theory. Intersection is the points that they have in common, or that are contained in both of them, of the domains of the original function. Functions. Okay, so let's do a couple quick examples. One thing about it, if you're doing division, you have to remember that the denominator, whichever function is in the denominator, cannot equal to 0. Okay, so let's do a quick example of this. We're going to have two functions. F of x is square root of 4 minus x squared. G of x is square root of 1 plus x. So first thing we're going to do is find the domain. And sure enough, the stuff that was in the last chapter is back. So what I need to know is that 4 minus x squared has to be greater than or equal to 0, or x squared is going to be less than or equal to 4. Okay, now important thing to remember here is that it's not so much x, but this x squared term is going to have to be bigger than 4. Excuse me, less than 4. I had that backwards. This part's right, but when you switch them around and you divide by a number, that has to be bigger than or equal to 0. This one has to be less than. Okay, so the square of this has to be less than or equal to 4. Okay, so when we take the square root, we don't have a problem with the positive one. So we know that x is going to have to be less than or equal to 2. The problem is with the negative 1. Okay? Now the problem, so if we do x is less than negative 2, then we bump into numbers like negative 3. And if I plug negative 3 squared in here, I end up with an imaginary number. The other thing you can do is actually go in and graph this thing and look at it. And you notice that the domain of this is between negative 2 and 2. And the reason being between these numbers right here, between negative 2 and 0, are the ones that when you square them are going to be less than 4. These numbers out here are going to be greater than 4. So my domain then is going to be written as, and we can include them, negative 2, 2, 2, and we include those numbers. Okay, so now let's come over and find the domain of g of x. This one's going to be a little bit easier. 1 plus x has to be greater than or equal to 0, or x has to be greater than or equal to negative 1. And we can write that as negative 1 to infinity. You don't include it. Okay, now we want the union of these two, and when you look at it at first, it's not all that easy to figure out. What I always do is I will actually draw a number line on these. So there's negative 2, negative 1, 1, 2. I'm going to come in and let's draw my domain for this. So it's going to be numbers between -2 and 2, and it's going to be all of these. And this is F. So now let's come back over then and deal with G. So it's going to be -1, and we'll include it. And then it will be everything over here. And that is G. So now we need to look at what they actually have in common. Points which are in both of them. Well, obviously anything out here is in neither one of them. Anything in between here is only in F, but not in G, so it's excluded. So this is the first point at -1, where we have points in both of them. And as we go along, we see we still have points in both of them until we get here at 2, and then F drops back out. And these points are excluded because while they're in G, they are not in F, and remember looking at the intersection. So the domain of this then is going to be -1 to 2. And that's how you find it. Now, you also have to find F plus G. Now, the interesting thing is, this is going to be the domain of addition, subtraction, and multiplication. So F plus G, I simply add them. That's going to be square root of 4 minus x squared plus square root of 1 minus x squared. And no, you cannot combine those because of the addition. F minus G minus F times G. Now multiplication, you can combine these. You're going to have 4 minus x squared, 1 minus x squared. And when I do all of this, it worked out to be 4 minus 4x squared minus x squared. What did I do wrong? Oh, this is a 1 plus x squared. This is just 1 plus x. No wonder. Okay, so I've got 4, which is this, minus 4x minus x squared plus x cubed. And then to divide them, we're going to have 4 minus x squared over 1 minus x. Remember, you can't have a radical, so you multiply the top and bottom by the radical. And we've already done that up there, so that's going to be the square root of 4 minus 4x minus x squared plus x cubed. And yeah, I've got it in reverse order. Then the square root of these is going to give me 1 minus x. And here the domain is going to be a little bit different because we're going to have to exclude 1. X cannot equal 1. So the domain then will still be -1, but I will go up to 1, but I can't include it. And then that will union with 1, 2, 2. And I include that. And that's the difference on that one. Okay. Let's work another quick example here of what I just did. F of x is 2 over x. G of x, 4 over x plus 4. So the domain on this one is going to be all real numbers, but x cannot equal 0. The domain of g of x is going to be all real numbers. X cannot equal -4. Okay? So let's come back in then and let's do our number line. So let's deal with f first. So I know it's going to be all real numbers out here, but it cannot be 0. So it can be anything out here or anything out there. It just cannot be that number. So the next thing I'm going to do then is take a look at this one. All right, well, I know on this one I've got to exclude -4, but it can be anything out there or anything out there. So basically the resultant domain is everything in common, which is all of these points, but I can't use that. So the resultant domain is going to be R, but x cannot equal -4. All of these are in there, but remember this point right here is not in F. So x can also not equal 0. But all of everything else over here is all right. So here's the domain of our new function. Okay, so here's something new. So I don't think I talked about this in Algebra 2 last year. If I did, it won't hurt to hear it again. This is called composition of functions. And this is part of what you're going to be doing. Let's take two functions, f of x g of x is that. Okay. Now composition is going to be written a couple ways. You might see it written like this. F with an open circle G looks like fog, and that's the way we do it. Or you can also sometimes see it written as f of g of x. And essentially, you might see it written like this. This sort of tells you what we're doing. What you do with fog is you take the function g. So you take the back one, and then you put it in to f wherever you have an x. So the first thing I want to do then is start out with f2. I've got an x. So I come back in, and since I've got that, I'm going to pick up my g of x. That's 4x minus 1. This is what I call g for x. We're swapping g and x. Plus 2, which is from my original f. Now you distribute. You end up with 8x minus 2 plus 2. Those go to 0. So that gives me 8x. And that is fog. Okay, let's deal with Goff. Notice these are in inverse order. So what I do is I take f and I put it in wherever I have an x in g. So I start off with g 4 times, now I've got an x. So I take f and I put it in. 2x plus 2 minus 1. Distribute, I get 8x plus 8 minus 1, or 8x plus 7. And this is, this is Goff. Okay. So, one more here. Let's deal with FOF. This looks strange. But all it is I take f and I put it back into itself wherever I have an x. So here's my f. So I start out with 2 times. I got an x here, so I put f in its place. Which gives me 4x plus 4 plus 2. X plus 6. And as you can see, dog, you just take g and put it back into itself. Okay, so this looks pretty good, and it's not too bad. Now the question then becomes, what are the domains of these things? Well, what I always do is I go in and instead of looking at the original, I take a look at the domain of the resultant function. This is all real numbers. This is all real numbers. And the domain of this is also all real numbers. Now again, you're sort of dealing with the intersection here of these two. So because this was all real, and this was all real, the resultant that came out of there is also all real numbers. Okay, so this is one type of problem you're going to deal with. Now, what do you do if you end up with something written like this? Which can also be written as fog of 0. That shouldn't be an O, that's a 0. Okay, well, as always, you start in the back. So what you do, and we'll deal with the same functions we had before. No, actually, let's deal with different ones. So let's say f of x is 3x minus 5. G of x equals 2 minus x squared. So what you do is you take the 0 and you put it into g. So g of 0, which is what this is, and remember these are interchangeable notations. You'll see it written both ways. I'm going to expect you to recognize it both ways. 2 minus 0 squared, which is 2. So now I take that number right there and put in for x in f. Because my next step here then is to take this thing and put it into f. So the number I got out was 2. So f of g of 0, all right, which we know is 2. So I'm going to come into my f, and I'm going to put 3 times 2, which is my g of 0, minus 5, which equals 6 minus 5, which is 1. So that's what that one is. Okay, and you see the trick of composition is always start at the back and work your way forward. So what are we going to do if we get a mess like this? I'm compositing 3 different functions. The rules didn't change. First thing you do is you take this and put it into there. So I'm just going to find g of h. G composited into h. So what this tells me is I'm going to take h, which is this thing, and put it in to wherever I have an x and g. That's going to be the square root of x minus 1. So there's that one. Then I take this guy here, and I put it into f, wherever it has an x. So f composited with g of h is going to be equal to, so I take this. So I've got the square root of x minus 1. Put that in for that one, minus 1. And there's your answer, right there. So essentially what you're doing with these is you're dealing with two parts. You've got two composited problems. First you do g of h, composite h into g, and then you take that result and you composite it into f. And it's the same idea if you end up with 4 of them. You take this guy, and you composite it into that, and then you take that result and put it into f. Okay, so with that said, the last thing then is I'm given a function h of x, x minus 9 to the 5th. Oh, I forgot something. Let's come back and take a look at the domain of this guy. Well, the only problem we have to worry about is when that one. So no, x minus 1 has got to be greater than 0, which means x has got to be greater than 1. And that's my domain. Okay. And what they want you to do is write this as fog. Okay, well, what I always do is I start on the inside here. And that's going to be my g. So I'm going to let g equal x minus 9. All right, and what I'm doing to that then is I'm going to raise it to the 5th power. Now remember in fog, you take this in and put it in for x in here. So f now is going to equal to x to the 5th. Let's take a look at what fog looks like on this one. So I'm going to have my x here. And remember, I'm going to take this and put it in. So it's going to be x minus 9 to the 5th power. So these are the two functions you need that are composited into it. And this becomes real important in calculus when you're going to have to break these things out.